afternoon, everybody. Good evening, depending on where you are joining us from. Welcome to ML Study Jams Machine Learning Uyo. So, like we all know, ML Study Jam is a track that aims to get in people into the field of artificial intelligence, into computer vision, deep learning, natural language processing, and a whole lot of applications of artificial intelligence. And this year, we have this particular cohort, we have partnered with TensorFlow User Group Casablanca. We have Sarah from TensorFlow User Group who will be facilitating the session today, and throughout all the Mondays we'll be having the session. And we also had always artificial intelligence lab to as well as partnered with them to be able to have a wider audience reach out to make so that this bootcamp can be made available to a wider audience. We also partner with Computer Vision Africa, a non-profit community aiming to address the problems we have in Africa using the problem of computer vision. So, thank you everybody for joining. So today officially it starts the first day and the day one of our ML study jam. And today we'll be looking at intro to artificial intelligence. We have what is artificial intelligence? We are looking at artificial intelligence. We use it everywhere. We use it every day. How do we, what does it, how does it work? What is the underlying principle behind all these things? So today, starting the first day, so to give you a brief overview of how this program works, every week we are going to have sessions. We are going to have session on Monday, Tuesdays, and Thursdays. The tracks has been made available in our groups, in our communities, and posted online. So for each of these weeks, we will have sub sessions related to what we have, as the key topic for that week. So it's gonna end towards the first week of October, and so feel free to share to your different communities and other people to join as well. So starting right away, I can see Obo from Udonbat. Thank you very much, sir, for joining us. Thank you. And yeah, so before handing over to our speaker for today, I would like to read to say a little thing about our speaker. So when first I had a chat with Sarah, I didn't really see the possibility of having this, but thank you very much, Sarah, for accepting to facilitate the session. Yeah. So Dr. Sarah.
I'm sorry, I lost you. Victor? Victor? Okay. Christmas. Sorry, Victor, you froze.
Okay.
Victor, you froze.
Okay, can you hear me now?
Yeah.
Okay, so Dr. Sara El-Ateif is a Google developer expert in machine learning and NVIDIA DLI instructor. Her research at the intersection of AI and healthcare focuses on developing innovative solutions for pressing global health challenges. She is passionate about mentoring the next generation of AI and professionals. Personally, she has done a lot of research and a lot of work about AI and healthcare. So at this point, I will hand over to Sarah to take on the session. Yeah, thank you very much, Sarah.
Thank you for the invitation, Victor. So I will skip my intro. So I will be briefly introducing what AI is, talking about its applications, how is the like machine learning pipeline is, types of learning, neural networks, and then some metrics. So what is artificial intelligence? So we can think of artificial intelligence as a set of algorithms. So their goal is to replicate how we human beings learn. That is like, how do we process information? How do we take decisions? How do we see this information? How do we extract, relevant things from it and stuff like that? Artificial intelligence is the big domain. This big domain has something called machine learning and then deep learning. So machine learning is a part of AI that uses statistics to improve the way machines learn. While deep learning, that is actually a part of machine learning, a subset of it, it allows learning from complex data using neural networks. That is like, we use much more complex architectures so we can understand the data. But what is really the difference? So in machine learning, it is us, the human beings, that perform the feature extraction, and the model then does the classification or any kind of actual task. Meanwhile, for deep learning, it is actually the model that performs all of these things, that it performs the feature extraction and then the other tasks, that might be classification or anything like that. I will be talking about what feature extraction is in like towards the end. So some of its applications. We have different applications in AI. Actually, you can use AI about everything, as long as it's supposed to be learning something, as long as humans are doing it. It is possible for AI to do it if we have the right data and the right way to frame the problem. For example, in the medical field, there are different ways we are using AI. So for example, we're using it to detect cancers, any kind actually of disease or complications. For example, it's used for breast cancer detection, melanoma detection, using images, or using actually any type of data. So for example, there is an app that detects respiratory problems, and it uses, like kind of like only like textual data, and you just like choose some kind of, you click on some kind of buttons, and then it helps you detect what type of respiratory disease you have. Then there is a really cool application called Buoy Health, and it's a chatbot for understanding symptoms. So it's kind of like help you diagnose what you have by you answering a couple of questions. There is also a way to, kind of like, instead of analyzing only one type of data, we analyze different types of data to come up with a certain, perhaps, I don't know, plan of treatment, or kind of like improve the way a disease might be detected. So for example, here they're using video stream, audio, vital signs to monitor neonatal behavior. So why are we trying to do this? Because usually there are a lot of complications in this neonatal process. So instead of using only one information, using different information will be able to provide us with better insight and a much more improved performance of the models. So what is a typical ML process? So based on Uber, this is like a typical process. So we start by first understanding the business needs. Practically, we start by understanding what is it that we want to build and why do we want to build it in the first place. Then we define a minimum viable product. That is, what are we going to build at first? What is it that we're going to build an initial, app or product that will help us to understand if this is doable or not. Then we actually start refining the minimum viable product to build the full product. That is, we start collecting the data, preparing that data, training the models, and then evaluating them. This is the prototyping phase. That is, we're trying to kind of like build the model, but in phases. This is what we call prototyping. That is, we are going to, it might be that the model will not give us good results. We will go back and then, redefine the whole process, get more data, or improve the data preparation process, or perhaps change the model and train another one. Then in the production phase, what we're doing is that we're going to push the model that we are convinced with to production for people to use. And that is, we start to productionize the model, deploy it, and then obviously make predictions. And after that, there is something called, here they call it measure, or you can call it maintenance of the model. That is, now we need to monitor how the model behaves in real life. That is, when the users are using it, how is it behaving? Is it giving some new, is it giving some new errors? Perhaps should we retrain the model on this new data or something like that? And then we gather and analyze these insights. So we might even like add more features to this model. Remember, this is an iterative process. That means we might go into the market, the model is available, everyone is using it, but then it crashes down or it's not useful anymore. Then we go back and define the business needs, and then prototype, push to production, and measure once again. Now, what are the types of learning? We have supervised and unsupervised learning, as well as reinforcement learning. I'm going to be discussing supervised and unsupervised as they are the most used types of learning. So for supervised, the difference between it and unsupervised, for example, for classification, let's see this example. We have images of babies, and then we have images of adults. So we feed the image to the model, and then we request the model to tell us if this is an image of a baby or an adult. So in here, we already provided the model with the image of the baby and the adult, and we provided it with the labels, which are baby, adult. That means this means this. This is what we're telling the model. And then we're expecting the model, after we give it the image, to tell us what the image is about. So this is part of this is part of supervised. Supervised is that we provide the model with an actual label. That is, we give it something and tell this is what it means. So we try to answer the question, what is it? And then obviously, when the model is training, it is actually drawing a certain kind of like function that tries to distinguish between the different classes that we have. So we can perform the classification. Now, for regression, which is actually tackles numerical tasks. That is, when we are trying to, I don't know, let's say we want to buy a house, and we want to know how much it will cost us. We would use regression and then give us priorities or properties about the house. It has, I don't know, 2 bedrooms, 4 bedrooms, and then 1 huge salon or something, or a huge garden, something like that. That would be, help us define how much it costs. So in regression, what the actual function is much more linear and follows the function y equals ax plus b. Now, in unsupervised, we do not give the model any labels. We kind of like only give it the data and expect it to kind of like find some patterns and classify each one of these patterns into a certain group. So here, for example, we have as input images of babies, men, and then women, right? And then we feed them to the model. So what the model does is that it is providing us categories of babies, and then the women, and then the men. So this is what we call unsupervised learning. This action is called clustering. That means we put these different data into several different clusters or groups. Sorry. Let's wait for it. So this is how clustering happens. We have different data points, and then the model will try to put each data point into actual groups. Now, for reinforcement learning, so for reinforcement learning, what we have is that, let's take it this way. Let's say we have a baby, right? The baby enters the kitchen. And then when it enters the kitchen, it touches the fire, right? What the baby will do is that it will try to draw, obviously, it will draw its hand away. And then after that, it will never, never, ever touch that place again. So how can this be translated into AI? So the baby is the agent. It is the AI that is trying to learn. Let's say the interpreter is perhaps the mother or the father. And then the action here is reaching out towards the fire. The environment is the kitchen. So if the parent sees the child reaching out for the fire, for example, they might scold them. So in AI, we usually will either reduce points or actually punish the model. But if the baby, for example, does not reach out to the fire, then the mother or father will reward the child, right? In this case, in machine learning, we might give points or different ways of rewards. We have different ways of doing this, but this is practically what reinforcement learning is about. It's practically how we learn from mistakes and from doing things that are good and we kind of like get rewards from. Let's talk about neural networks. So neural networks are one of the very basic things we should be learning about in deep learning, because they are the basic architecture we use to learn the complexities of the data, to represent it, so we can get it to do a specific task. So a neural network is kind of like a couple of neurons. So the neurons are those, you see those round things that are blue, those are the neurons. The input is going to be, I don't know, either a matrix or a vector, depending on the type of data we're processing. So we have the input that are the features. Then we have the hidden layers. The hidden layers are the ones learning from the data. And then we have the output, which is the prediction. So in this case, we say we have a neural network of 4 layers. We include the actual output. We do not include the input, but we include the actual output into the number of layers. As for the number of hidden layers, we have only 3. So how do these actual neurons learn? So in every neuron you see, so before, like when we have the input and information, we have it go through an activation function. And then, depending on the value, the activation function can be as simple as, is it bigger than X or smaller than Y, for example. So if it's kind of like, if it meets the criteria, then we activate the neuron. That is, we're going to pass the information to the next neuron. If it doesn't, then we will not pass the information. That's practically it. So let's take this example. So we have 5. 5 is, well, based on the criteria we have, to activate the neuron, the data that we have, the input, needs to be lower than 10. As long as it is lower than 10, we will activate the neuron. So is 5 lower than 10? Yes. So we will activate the neuron. Otherwise, we won't activate the neuron. So there are activation functions. Activation functions, the most used ones are sigmoid, and then ReLU, and then softmax. I'm going to be talking about the ones that we have in the middle. So for sigmoid, it converts the weighted sum to a value between 0 and 1. And the function is 1 over 1 plus exponential of minus x. So practically, we have values after anything goes through sigmoid, we have either values of 0 or 1 or values between 0 and 1. And usually we have a 0.5. And if, let's say, if our value is higher than 0.5, then we consider it is 1. Otherwise, if it is lower than 0.5, we consider it as 0. Let's say, for example, we're trying to classify between cats and dogs. And let's say cats for us is 1, dogs for us are 0. Let's say the value of the network after calculations, we have received 0.6. Seeing as 0.6 is higher than 0.5, that means that we are going to output the class as 1. I don't remember, did we give the cats 1 or the dogs 1? I believe it was the cats. So we will have the cats as the class. So for ReLU, which is rectified linear unit, it often performs slightly a bit better than a smooth function like the sigmoid, by being much easier to calculate. So why are we, so what it is first in a mathematical sense? So what it does is that it takes the maximum between 0 and our number. So what does that mean? If the number is lower than 0, most likely it's going to be 0. that is a number that is negative is going to give us output of 0. But if the number is higher than 0, obviously, almost all the positive numbers are higher than 0, which makes it any positive number is going to stay as it has gone through. That is, if we have 0.1, it's going to be 0.1. That is what is going to be outputted. So why are we using ReLU and instead of sigmoid? Because ReLU gives us a much more better flexibility on representing nonlinear data, which means it covers much more values than sigmoid. And it helps us avoid the negative values as much as possible. So common architectures, there are several and thousands, and especially now we have even more architectures that have been let's say created. Okay, so the very typical ones for NLP, natural language processing, we use things like recurrent neural network, long/short-term memory, LSTMs, gated recurrent units, and then when we are trying to perform any kind of similarities or generation models, we use things like autoencoders, variational autoencoders. Then we have things like deep convolutional neural networks, right? These are usually used in images. We have also generative adversarial neural networks for generative AI. Then we have the very, very, very much old models like deep residual networks. And then we have also for machine learning, the traditional machine learning, we have support vector machine. So these are different models. And these are what I would like to call the basics. That is, in reality, all of these different architectures are not exactly specific to computer vision or NLP. Although obviously we see researchers and even practitioners use specific architectures for specific fields. In reality, and if you check out recent research and even some of the old research, any type of architecture, if you're talented enough, you can use it for different types of data and different types of domains. So what is feature extraction, right? So in simple words, how does a computer know it's a cat or motorbike in this example, for example? So what it looks like is like what we call the feature. So we have a certain image, it goes through a preliminary processing, then we have the extracted features. So what are these features? Features are just properties or characteristics of an object. It's what differentiates a certain object from another one. So for example, if we have a cat, what do they have that is so different from human beings? We do have both, we both have ears, right? But their ears are up here on their head. We have two beautiful eyes. Their eyes have a very much better, has bigger fundus than ours. Then they have, kind of like mustache in here, and they have a beautiful, very short nose. So they have very certain specifics that we do not have. Obviously, that the motorbike doesn't have as well. While a motorbike has something like, those beautiful circles that it rolls with, and then it has the front side of it, the back side of it, and then some of its other features. So in convolutional neural networks, for example, we have a certain image, seen as it is mostly used in image. By the way, I would like to remind you that this can be used for anything, because most of the networks, what they do is that they need to transform the data they take in into some kind of numbers. Because if you remember, in computer science, the computers only understand 0 and 1. So anything we're going to be feeding a computer is practically 0 and 1 coded. So the images we have, what we try to do with CNNs is that it goes over matrix, and then it's kind of like reads the pixels, and then extract features based on feature matrix. We also call them filters. We extract some specific features. Let's say, for example, we have a filter that detects the edges. So the first filter is going to only give us the edges of the image, so on and so forth. Usually we have at least 3 to 4 filters. Obviously, that's the lowest one. We can have more than that, depending on the complexity of the data and all of that. So after that, after we go through the convolutional neural neurons, we go through then the fully connected layer. So practically, all the data that we have gathered, all the features we have extracted, they are still in a higher dimension. So for example, here, they are in 7 by 7 pixels towards the end, before the fully connected layer. So what happens is that 7 by 7 pixels is going to be 7 multiplied by 7, that is 128 features. Practically, all the pixels that were in form of a rectangle are going to become a vector. That is a very huge rectangle that has much more height, like the kind of like its length is going to be higher than its width. And then obviously we kind of like have probabilities. We're using sigmoid or any kind of activation function. Obviously, because we're using here multi-class classification problem, we're going to be using softmax, and it's going to give us a probability for each one of these pixels. So we know if it's 7 or any kind of other number. So there's also the transformers architecture. So the transformers architecture, what is different about it is that it has a couple of interesting components that we do not have with the typical models like RNNs and LSTMs. It is that it has the transformer block. The transformer block has something called attention modules or multi-head attention. So specifically, attention is like how important when the model is looking at the information, where is it exactly looking at? So this is kind of like what we are trying to replicate with attention. So, and attention is actually just a bunch of matrices that is composed of queries, keys, and values that we compute together to kind of like know where the model is looking at or should actually look at, because, apologies, that feature is much more important than the rest of the features. I don't know. Let's say, for example, our hands. If you look at the fingers, it's much more important than you looking at an area of the finger, for example, this area or this area. Because if we can get the shape of the finger, we will know it is a finger. But if we get another patch of skin, we won't really know if it's, just the back of the hand, or is it exactly a finger? Is it well? So we need to look at specific areas. So how do models based on transformers or any kind actually of NLP-based models, natural language processing models, actually work? So practically, as with all the kind of like modalities of features or whatever type of data we're processing, we have the data come in. For the text, it is split into, let's call them words. So the proper name is tokens. And tokens are different from one model to another. So it's a strategy. Is it going to be the exact word, or is it going to be the root of the word, or what is it going to be? Depends on the model. But the thing that we need to remember is that it is splitting a sentence into a couple of words to be translated into embeddings. So kind of like an encoding way, a way to encode information to make it into numbers. But not just any kind of numbers, but representative numbers that actually remember even the position that word has been featured in. For vision transformers, it's very similar to the text transformers, but instead of having, the pixels that are taken, we take a patch of the image, a certain area of the image that is processed. So for metrics, how do we evaluate machine learning models or deep learning models for that matter? We have things like confusion matrix. The confusion matrix provides that with an actual much more holistic view of what is happening inside the models. That is, where did the model fail? Where did the model succeed in its prediction? Where is it making the most mistakes? Why is it making those kind of mistakes? Recall is mostly given like to provide the probability of detection or hit rate, how much values were correct. Precision is much more to give us how much did we get like correct and then false. And then accuracy is specifically how does the model, kind of like how does the model stack in comparison with the wall, with the wall, the things it had made mistakes on and the things it has given us the right predictions for. And then F1 score is usually there to kind of penalize the precision and the recall metrics, specifically when we have imbalanced data. So it doesn't let recall or precision take over just because their values are higher. It kind of like balances between them. And then MCC, or Matthews correlation coefficient, is usually much more useful when we have different multiple classes, a bunch of them. It is also used to kind of like avoid issues when we have class imbalance. So a class imbalance is that we have much more information or data from a certain class than another class. So for example, in here, this is a confusion matrix. And what we're trying to do is binary classification between cancer and non-cancer. So here, as you can see, so totally we have 12, let's say, images or 12 data points. We have here the actual condition, that is the real label. So we have 8 cancer and we have 4 non-cancer. So for cancer, the model, that is the number of data points that were predicted correctly for cancer, that means we had cancer, the model predicted cancer, are 6. We had cancer, but the model predicted non-cancer. This is what we call false positives. And usually this is the metric that we always want, especially in healthcare, to be the lowest, because we wouldn't want to classify someone that has cancer, especially if it's a cancer that is very dangerous, to say they do not have such a cancer. So we try to kind of like lower it as much as possible. By the way, these metrics, their importance changes from one area to another, from one business problem to another. So please pay attention to what is important on what you're working on, not just generally. So for the number of false negatives, that is how much, the kind of like the model gives a wrong answer, but is not a catastrophic answer. So let's say, for example, here we have 4 people having cancer. So the number of false negatives, that is the model said these people had cancer, which obviously they didn't have. So it's 1. Why did I say it's not a catastrophic as much as the FP? Because if someone, let's say we found that someone, let's say the model told us someone has cancer. It's very simple. We are just going to go through tests and see if that person truly has cancer or not. If they do not have it, then the patient is lucky. We're very happy for them, but nothing happened. But if someone had cancer and we left them to go home, that's a problem. The cancer might kind of like advance to an advanced stage, and it creates all sorts of headaches. So the number of cases where the non-cancer was predicted as non-cancer here is called the true negative. Negative, that means the patient does not have cancer. Positive means that the patient has cancer. Obviously, this is applied to this use case, the cancer and non-cancer. Do you have any questions for me? Please go ahead.
Sarah, for the presentation. I really enjoyed that. Thank you for the insight. So I want to ask, what's the difference between accuracy and AUC?
Area under the curve. So accuracy is like has different metrics. If you check it here, it takes into consideration true positives, true negatives, and then the precision, the actual P and N. So this is like the I think this is a mistake. The TP and TN, yeah, I just forgot to add the T. So the true positives and true negatives. But if you look at area under the curve, what it gives you is that it is actually accounting for precision and recall. And what does precision and recall have? So the precision focuses on the TP, the true positives, and it takes into in consideration the false positives. Meanwhile, recall takes into consideration also the true positives, but it looks into the false negatives. So if you get both of them inside, like let's say, for example, if you account for both of them, what are you accounting for? You're practically accounting for all of the metrics apart from the true negative, right? But in accuracy, we're actually accounting for only this side of things, right? Only this side, this one here, the diagonal of the matrix, of this matrix. But if you have AUC, it is almost accounting for all of this area, which is, if you look at it deeply, this is the area we care about in this kind of case, right? So AUC kind of like usually gives you a much better accurate answer if your model is doing well or not, and it actually helps provide you with kind of confidence levels. So what does that mean? Let's say, for example, my model says that I can accurately predict if someone has cancer or non-cancer at 90% confidence. How will you know that confidence? It is by using AUC and by plotting the precision and the recall. That's how you know the confidence at which the model, can predict cancer or non-cancer. Does that answer your question?
Yes, it does. Thank you very much.
You're welcome. Any other question? Let me see.
Okay. Ernest, you can unmute yourself and speak.
Okay, hi guys. Still on the metrics, I think there's a typo. I think
this one is TP and this is TN.
Yes.
And actually, like, it misses a couple of other ones as well. Let me check it out.
Yes, and even in the matrix, you have.
No, this one is right. It's because it is a completely different metric. Let me show it to you. So here, so the P and the N are the positive and the negative. The positive and negative are actually completely different metrics. It's related to, usually they are related to the false positive rate and the negative positive rate. I actually shouldn't have used this here. It is very confusing. Sorry about that. I will update it here later on, so I can, give you the right one. I mean, the easier one. Because here we account for all of them. We count for PP, TN, and FP and FN for the accuracy, the under one. Okay. As in divided by.
And yeah. also the false positive is actually the false negative, and the false negative is actually the false positive.
In this case? In this case? No. Yes. Not in this case, no.
Because the false negative is when the model predicted something that not actually exists, but it actually exists.
So here the thing is, the false positive is if someone has cancer. So this is the real label. Someone has cancer, right? Yes. But the actual the model told us they do not have cancer, right?
Yeah, so this is
the false positive.
No, I think that's a false negative.
No, this is the false positive. Because the false negative is, let's say someone actually does not have cancer, but we say they have cancer. This is totally fine. But this one is not. And as I told you, in medical field, We always want to make sure the false positive is the lowest possible, because this is the most dangerous. We say someone does not have something when they actually do have the disease. This is much more dangerous than saying someone has a disease, because we can test after it. Just check it out. If you check out the confusion matrix, this is what we're going to find. You can actually even check it out here. Here is the link.
I think you can go to the previous slide. You will see that.
Yeah.
You see?
Yeah, I see that.
Yeah.
But this is
So it's a false negative, not a false positive.
this is really strange.
The actual condition is positive, but the prediction is negative, so it's a false negative.
Yeah, but the thing is, this is not, if in terms of medically speaking, this is not right. You see what I mean? Because in the if it is medically speaking, usually what we would want to avoid is someone actually like having cancer, right? And us telling them they do not have cancer, right? This is what we usually want to avoid, the kind of state we want to avoid, right? So normally there is actually some kind of issue with this example, but usually, like, even if it was me, for example, this is how I would go with the confusion matrix. There isn't a problem with this example.
Yeah.
Okay, so we have another question in the
Go
chat
ahead.
section. So the question is, okay, the question actually from Obon von Udombat. What are the available tools to begin to explore and practice this hands-on? Meaning,
There are
what are
a lot of tools, right? So there is, for example, TensorFlow, there is PyTorch, there is, if you're doing 100% machine learning, you can actually just use Scikit-learn. So there are like a couple of other tools you can use. But yeah, this is practically the most popular ones. There's also JAX. There's I think there was something called MNet before the TensorFlow and the PyTorch triad, but there are like a couple of other ones.
Okay, so thank you very much. Abraham Obianke, you raised your hand. You want to ask a question?
Okay.
Go ahead.
Yeah. So I want to ask, do we have control over over the values on the confusion matrix while training model?
Well, you do not exactly have a clear control. Like, you can't, let's say, for example, I want to increase this, you will, I don't know, put some magical number, it's going to increase it. No, that's not how it works. But you do have some control over how to improve the performance of your model. So you can do things like add more data, improve the data quality of what you have to be more representative, right? You can even add more regularization to challenge the model to learn better from your training data. There are different ways you can improve the model and how it reacts to your data, or improve the data and obviously improve the model performance as well sometimes. But can you control exactly what your model outputs? That's not exactly the case, no. I mean, we wish we could, because obviously otherwise we would make them all have 100% accuracy.
All right, thank you very much.
You're welcome.
One more question I would like to ask. In a model I trained, it achieved an accuracy of greater than 90. I mean, greater than 90%. But when I plotted the AUC curve, it was giving me 70, 50. The accuracies was kind of very low for the AUC. Could there be a reason for that?
Yes. So the
AUC was low, but the accuracy was high.
Well, as I said, the accuracy does not most of the time account for class imbalance. One of the best metrics to use is F1 score or AUC. AUC and F1 score both penalizes precision and recall. And usually accuracy has some elements from precision and recall, but it does not penalize them. So when you have a class imbalance, let's say, for example, here we do have a class imbalance, right? We have 8 cancer and 4. The best way, and look here, so F1 score is actually much better than accuracy, especially in here. But in some cases, you might find accuracy much better than F1 score, especially when you have some really, really bad class imbalance. Why? Because we do not account for kind of like the rest of the other metrics. So we're kind of only looking at the good side of things, if you want to look at it this way, right? So accuracy only looks at the very bright side of the model. But if you check F1 score and if you check AUC, they give you a much clearer version of what is happening with the model throughout different phases, especially for AUC. That's why I was talking about the confidence, which we call CI. So this is like, how confident is the model at point where precision, let's say, for example, is at 70%, 75%, and recall is at 85%. How confident is the model in its own prediction, right? So this is kind of like the type of answers you really do need if you want a better overview of the performance of your model. Otherwise, accuracy only looks at one side of things and does not, most of the time, account for a class imbalance. That's why we would usually, actually, most of the time, we're always using AUC. Very, very, very rarely do we use accuracy. You're welcome. But by the way, it's like, you're welcome. So as TP, FN, and FP do change based on the task at hand, there is something else also that changes based on the task. It is these metrics. Let's say, for example, sometimes accuracy is actually the right metric you need for the problem you're solving. But sometimes you actually care much more about precision than any of these metrics. So it all depends on the problem you're trying to solve or whatever you're trying to model using AI. So please do pay attention to that. There are actually much more different metrics than these 4 well-known ones. As you see here, there is a bunch of them. We have and we still do have more than the ones you see here. So it's best to know what is the best metric to use based on the use case you're tackling.
Okay.
All right. Thank you very much.
You're welcome.
Yeah. So we have Gideon actually raised his hand. So Gideon, feel free to unmute yourself and speak and ask your question or contribution.
Please do. Meanwhile, let me find the right expression for the P and N so I can give it to you. Right. This one here.
Okay.
Hey, Assalamualaikum.
Walaikum assalam.
I have one question. I have a beginner on this field on AI and machine learning, deep learning. Can you explain like how can we start? And like I have my teacher explained me this method, but like on you say first you say that it's second is false positive, but it's false negative. Like a little bit confusion on that method. And how can I start on that? Like
What do you mean? Can you repeat your question? I didn't get it. Sorry.
I have a beginner, like I have learning on the generative AI field. I am working on the generative AI, but I want to learning about the machine learning algorithms and deep learning. So how can I start? And my teacher also explained these metrics. Like on second option must be like around false positive. Why the like false negative will be here? Why the false negative will become? On the second, like cancer or non-cancer, if it will be true to false positive.
I'm sorry, I'm not sure I understand your question.
I'm asking about the second matrix, like if like the cancer is not, uh, if the cancer and the model which predict is not, so it's false positive or it's false negative.
I don't get it.
Okay, okay, left it, but I explain me like how can I start in this field?
Okay, you can check out, for example, courses from Kaggle. They have something called Kaggle Learn. Let me show it to you. So this is Kaggle Learn. You will find all kind of courses. They explain actually almost everything to you from start to finish. You can check it out. There is also other courses from deeplearning.ai, if you heard of them. Okay, let me go to the chat so I can send you the link. There's also deeplearning.ai. They have some awesome courses too. You can check any of their courses, but specifically I recommend checking their deep learning course. So deep learn, either ML course or deep learning course. Deep learning if you're interested in deep learning, machine learning if you're interested in machine learning.
But they are
So
much,
yeah, you're
but
welcome.
there are so much paid courses like that.
What?
There are so much paid courses like on machine learning,
Yeah,
specialization.
Kaggle Learn is free. Kaggle Learn is free, and obviously there are lots of amazing courses in YouTube. Actually, even YouTube has some of deep learning AI's courses for free. Let's just write Andrew NG. Yes, this is like he has a lot of his courses that are on YouTube and for free. So for example, this one is free. You see, and this is the latest machine learning course, not the old one that we all studied.
I will try it. Okay, thank you.
You're welcome.
Thank you very much for answering the questions. We still have questions coming in as well. So
Mhm.
we also have a question here from IH saying Nejawi.
Ihsan. Okay, Ihsan, what is your question? My question is how we can approach our ML learning journey, especially in the era of generative AI. I mean, what are the core principles that we need to master? And also, if you had to start over, what would you advise us to do and maybe avoid? Thank you for your presentation. It's just awesome. Okay, so if you wish, if I had to start over, I would definitely start with Kaggle Learn. Kaggle Learn will give you it will not only explain the principles, but it will also actually provide you with information with practical things you can do. Like they teach you a concept and then they give you the example where you can apply it and learn about it practically, by coding. And this is the way I would do it all over. Learn, then code, learn, then code, learn, then code, so that it can stick faster, to my brain, and I can start actually building things. The best way to really learn is to learn by doing. It is good to learn, the theory, how it works. But I only invite you to learn the theory when you have already practiced something, because it's easier to understand the theory if you have already practiced it, It's easier to stick. You understand why they need to add X and not Y in a certain, point of the equation, for example. So in the era of generative AI, yes, the actual basics are the same. So understanding what is the difference between supervised learning and unsupervised learning and reinforcement learning is what is going to help you build better generative AI models, right? And obviously, there are lots of courses on generative AI, but if you understand the basics, especially the math, you will be able to understand how transformers work, and then understand most of the generative AI architectures out there. So for generative AI, actually, if you don't have solid foundations, especially in the math section of deep learning, it's very hard for you to go far in it. You can do fine tuning, you can leverage other people's models, but you won't be able to build your own. So yes, master, especially the math of deep learning. I think there is also the deep learning book from Ian Goodfellow. That's a great book to learn from. Let me share it with you. Ian Goodfellow. There are actually a couple of amazing resources out there. So
Yeah, actually.
just learn from them, to be honest.
Okay,
But yeah,
so I really buy the idea to what you said here, learning and coding as well, and they work really together, and learning a particular thing, and after learning, and let's say you want to start from the basics of machine learning to generative AI. I mean, that's really, really long before going to coding or the practical aspect of it. It doesn't really work that way. You really have to learn, and as you are learning, to practice as well. So we also quickly we have another question here.
I'm sorry.
What is-
I'm sorry. I will have to go because I have another meeting like
okay,
right now. So if you guys still have other questions for me, you can either ask them in the next session, or you can send them to me via my social media and I will make sure to answer them properly for you. Thank you very much for coming. It was really great to, interact with you and, kind of like introduce AI to all of you here. Thank you very much.
yeah, thank you
See
very much.
you.
Thank you very much. All right,
Thank you all.
bye. Okay, for those that have just joined us, this is the first day of our boot camp, ML Study Jam Machine Learning. We also quickly to answer the question: what's the difference between PyTorch and TensorFlow? Python and TensorFlow, they're actually a deep learning framework used to build neural networks. I won't really say there is much between PyTorch and TensorFlow, but PyTorch is really, really faster. And what TensorFlow does is that with TensorFlow, we can actually build these models instead of having to write code from prototyping after your research and looking for a developer. With TensorFlow, you can write this code as well, test it, and if it works perfectly well, push it to development server or development environment using something like TensorFlow Keras and saving it with one hand deployment in the cloud. So I'm going to drop links to our community groups, and thank you everybody for joining. Do well to
I haven't
subscribe
understood
to
the answer.
what did you say?
I'm the one who asked the question, so I haven't understood what you have answered, like the differences.
Okay, so what I was actually trying to say is that TensorFlow and Python each have special advantages that meet various needs. For example, TensorFlow offers strong scalability and deployment capabilities, making it appropriate for production and large scale application. Just like what I said, after making your research and you want to quickly prototype this model or make them available for development or production, you can use TensorFlow. And with extensions like Keras and TensorFlow Lite, you can actually serve these models. Whereas PyTorch excels in flexibility and ease of use, making it perfect for study and experimentation. probably when you the actual difference is that TensorFlow is optimized for model development and production and serving, whereas PyTorch excels in building experiments with data and it speeds up the process. Using PyTorch, PyTorch is really fast. That is just although the two have the same thing in common, that is just slightly different between the two. I don't even understand if I've answered your question.
Yes, you have. Oh, so you can't deploy a model with PyTorch?
You can deploy as well. You can. I mean, but I think for using PyTorch and TensorFlow, um, TensorFlow will work more better.
Okay, thank you. I've understood.
Okay. Yeah. So we also have another hand raised. Gideon, you want to ask a question?
I was asking, can you please send the slides for the lesson which Sarah had given?
Okay. So I don't have the link to the slides currently, but if you join any of our communities or any of our social media handles, this particular tutorial will be shared alongside with the recording on YouTube. So please do well to be open to see the link to the slides be shared across everywhere.
All right. Thank you.
Okay, thank you very much. So I've sent the link to the group. Do well to do well to join our community, follow us so that you don't miss out. We are going to continue tomorrow, same time, 4 p.m. FAT and +1 UTC. Thank you all for joining at this moment. Have a great day. All right, thank you. Bye.
Hello.
Yeah.
How are you, sir? Sir, I faced a problem that there have electricity for in my country, so in my location, that's why I can't join the classroom in the right time. So can I get the class record?
Okay. Are you in GDG Casablanca or are you in the
Sir,
machine learning
I
Uyo?
like to join the group in which WhatsApp channel which you provide in the comment. I think it's a private group. I give the request to join.
Okay, I've seen you now. I'm going to accept your request. So we don't actually want scammers inside the group. But at the meantime, the link to the recording will be shared in the group, everything, and across our social media handles. The link it will
Thank you,
be shared.
sir. Yes, sir.
It will be posted on YouTube and shared to everybody.
Yeah, you can share this here or WhatsApp group.
The repository,
Yeah,
yeah, it will be shared as well.
yeah.
Okay, so actually the resource we are learning is Kaggle Learn, and for this track, for this particular track, we are going to use Kaggle Learn for everything. So the link to Kaggle Learn, the resource we are using, will be shared as well.
Is this class will be conducted in every day in 9 p.m. in our as our country's time?
Okay, which country are you joining from?
I'm from Bangladesh, sir.
Okay, so this is currently 9 p.m. in your country.
Yeah, it's now 9. Now it's 7 p.m. But the meeting start on 9 p.m. as our country's purpose.
Okay. So I mean, It's actually afternoon right here. I mean, this is 5 at the moment, but I mean, I know we have this time in differences, but in our next bootcamp, we are going to consider everything. So we don't have classes every day. We have classes or we have sessions Monday, Tuesdays, and Thursday for every week. We have sessions Monday, Tuesdays, and Thursday for each week.
Monday, Tuesday, or Thursday. Yeah.
Yes.
Yeah.
Yeah.
Thank you, sir. I think it's really very helpful for us.
Yeah. Yeah. So
And
I'm going to send you a chat after now.
yeah,
Okay. Thank you.
thank you, sir. So I just
Uh,
give the request on WhatsApp channel, but no one accept me to the channel. May I send the request once again by canceling this?
okay. Yeah. 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 Think I've accepted your.
Okay, I again send the join request join the group.
Yes. Okay. 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 I've accepted your request.
Thank you, sir.
All right. Thank you. You're welcome.
So if possible, please share the today's class recording on that group. It will be very helpful for us.
The slides.
Yeah,
Yeah.
or you can share it. You can share
Yeah.
it on YouTube channel or others,
Yes.
wherever we can. It will be.
Yeah. 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 Everything will be shared. Everything will be shared. The slides, the
Yeah.
code, and it will be the entire tutorial will be shared on YouTube.
Yes, sir.
All right. Yeah. Thanks for joining.
Thank you, sir.
All right. Thank you.
Goodbye.
All right. Bye.